Good morning, ladies and gentlemen, dear guests. I should not stand on the screen. So, as you can see, my topic is domestic water supply from source to top and basic sciences. Actually, I am not going to talk about much on the basic sciences. You are already, a lot of you, I think, working on basic sciences. But I wonder if any of you previously study about water and how water comes to our house. Do you have idea? Maybe you have some rough idea, but you didn't actually study it, I think. Okay, why domestic water? Because water consumption is usually classified in three categories: agricultural use, domestic use, and industrial use. So in most of the world, more than 70% is used for irrigation. Therefore, I only talk about here domestic water supply. It's, the water running through your taps in your house. So, about water supply system, about little elements of water supply system to introduce you. Water sources and water abstraction, how we can take water from the source, and water transmission, because usually water is used quite far away from where it is taken. So it should be transferred. If it is supplied for use, it should comply with some standards. It should be like drinking water, for example. But in the beginning, I talk about you don't have to provide irrigation water as good as drinking water. Water is supplied to houses, it should comply with drinking water standards. Therefore, water treatment, if it is not complying with the standards, water treatment is important. And lastly, water distribution. Pipe networks that deliver waters to the houses in the city, for example. Yes, we mentioned about sources, treatment, and distribution, and abstraction, transmission, so forth. So source could be surface water sources or groundwater sources. And then usually if water is taken from surface water sources, is not readily complying with the drinking water standards, so it has to be treated. So treatment is important part, and then distribution. Here we show here the sources. Sources could be surface water sources like lake or dams or rivers, or the drawing here is not scaled, so this is to indicate the boreholes or wells, but so you should not consider it is like a scale. Pumps, if the water sources elevation is below the residential area, that the water will supply. Then we have treatment plant, that is for water. When we talk about treatment plant, there are two main kinds, wastewater treatment plant and drinking water treatment plant. So treatment, whenever you hear about treatment plant, there should be a difference between wastewater and drinking water treatment plants. And from all the way, all the pipelines called transmission lines or water transfer lines. So water transmission is an important part of this water supply system. And then storage or network. Network begins always with storage because you have to supply pressure to the network that is provided by storage tanks. So then distribution network, which is delivering water to every household in the residential areas. This is another way of showing the elements of water supply system. Here, wells and treatments, schematic display. Here, we can call up to here as production, because abstraction, treatment, and delivering to the distribution network part could be named as the production part, and then distribution to the households. Here again, abstraction, treatment, storage, transport, and distribution network. And before and after treatment plants, you can have storage facilities also. Drinking water should be potable, safe to drink, and it should be free of microorganisms, organic and inorganic chemicals, and also radionuclides. So it should be free from the health hazardous substance organisms. And also it should be palatable, aesthetically pleasing. It should not have color, odor, or turbidity or taste in it. So when people consuming, they should not have complaint about it. The aim of the treatment is to provide water that is both safe and pleasing to drink. So this is main difference about the domestic water comparing to irrigation water. Drinking water quality standard issued by various organizations. Turkish Standardization Institute also issued drinking water quality standards, but also every country has their own standards for drinking water. These are the only, because a lot of substances in the standards that drinking water should comply with. These are the only few examples. Inorganics, for example, arsenics, barium, boron, chromium, so on. And also some organic substances. The list is quite long, so I'm not going to give you all the detail. Just to give an idea that drinking water should comply with the standard that could be health hazard if standards are not complied with. Water sources I have mentioned. Surface waters in general and groundwaters are the water sources. As surface waters, we have dams and lakes and rivers. And as groundwater, we have springs and wells, hand-dug wells maybe, up to 20 or 30 meters. And deep wells that are deep and made by boring machines. And also infiltration pipes and galleries also used to abstract groundwater if the water level is shallow, water table is near to surface, then infiltration pipes and galleries could be used. I don't know if you can see all of you. No problem. Hocam siz de görüyor musunuz? Başka taraf. Yes. According to the source, we need different type of abstraction constructions. For example, this is water intake or water abstraction from river. Water abstraction part, because river is a long flowing place, you should decide which part that you will take water, and the place you have decided should be in terms of quality, and the quantity should be good in terms of, as I said, quality, and quantity should be available all the time. So if you are taking water from dams or lakes, these are river intakes examples, and these are, this is dam, and this is also, this could be lake. In the different times, water quality might be different in different levels. So water intake element should allow you to take water where the quality is better. So it has different depths to take water. Yes, these are more examples about the water intakes from the dam and the lakes. Sometimes, like here, it could be connected to a float that's staying on the surface, and the water is taken from some depth of from the surface. These are also river intakes examples. So water intake or abstraction part is also important, is water supply system. If you make it good, then or selection location is your location is good, then some of the treatment requirements may be reduced because of the only selecting better places. So there should be good analysis where water should be taken. This is to give you an idea. Konya is my city, in which 1,300,000 people live, and up to 1995, only groundwater sources was used in Konya to supply domestic need. But in 1995, this treatment plant is established and put in operation, taking water from Altınapa Dam. And this is the second one put in operation a few years ago. This is taking water from Blue Tunnel. maybe Turkish colleagues may heard it. Yes. Sorry? The first one, the water source is a dam, Altınapa Dam. The second one's water source is also dam, but it is delivered, I think, about 100 kilometers by pipelines and treated here. So it has also about more than 20 kilometers tunnel to deliver water. So delivering water or water transmission sometimes is quite a big job or quite important part of the water supply system. Yes, as I mentioned, until these two treatment plants put in operation, water source was wells, so groundwater was used. Groundwater abstraction is do not need any special constructions. You have to construct wells, so you extract water from the wells. And usually groundwater sources treatment need is minimum and usually do not need treat groundwater. If it is okay and complying with the standards, only safety chlorination, protecting water source from contamination in the network, distribution network, you have to chlorinate or disinfect. But there are maybe later we will see other disinfection methods, but the chlorination has some advantages to lasting effects, like lasting effects comparing to other, for example, UV light radiation disinfection. It doesn't have this effect. When you are deciding or selecting water sources, you should evaluate amount of water you need and the amount of water you can abstract from that source and the changing amount over the year. For example, if you can get water from a source for a few months, but the other remaining times you don't, you cannot get that amount, that source should not be maybe preferred. Also, quality change in the source should be followed for a long time, and that also important. Better quality and consistent quality should be preferred. And also, of course, distance of the water source to the place where you should deliver the water is very important. It affects the cost. Treatment requirements is important. And seasonal changes in quality and quantity in water source is important. So after evaluating everything, the cheapest and continuous solution should be preferred as water source. Water transmission is carried out like it depends on the amount of the water you are going to transfer, but sometimes it requires a big pipelines. You have seen on the way such construction. Do you know why it is constructed? Sorry? Yeah. Sorry? Yeah. Because this, you notice these pipes are pressurized pipelines. But in old days, we didn't have these materials or these pipelines. water has to flow openly on the channel, or hydraulically it is open channel flow. So it has to, the level of the bottom of the channel reduce, or level should be gradually going down to allow water flow. So this is the reason why this big construction was made, because we didn't have pressure pipelines. In pressure pipelines, it doesn't matter if the pipe goes down and goes up again. But in channel, water channel, if it can go down very quick, but can go can go up. So it has to be gradually going down. To provide this, whenever you have valley, you have to construct these big buildings to transfer water. Yes, water transmission line, free surface lines, as I mentioned just now, open channels and galleries working with hydraulically with this principle, and pressure lines, that is gravity flow, that means to flow water inside the pipe, gravitational force is used. Pumped water lines, or partially gravity and partially pumped lines. So this is, of course, free surface lines only used if big amount of water is abstracted, and the line or the distance has no up and down topography, so it is going smoothly downwards. Then you can use to transfer water with open channels or galleries. However, this is not always the case. Only irrigation water channels are usually built like this. So domestic waters are transferred usually with pipelines. So if the water source is in higher elevation than the transferring point, so water could be delivered with pipelines without any need for pumping stations. But on the way, if there is higher places than the water source in the elevation term, then you have to pump water to deliver the transfer line. Okay, these are the, fortunately, I put a lot of pictures that sometimes every picture I can talk, but without talking, pictures talk itself. So I can go a bit faster to complete all the slides. Afterwards, if you like to ask questions, you are welcome. These are, again, pictures from water transmission lines. And water is delivered from different locations, different topography, so different obstacles always on the way. These are aqueducts. These three are from Istanbul, around Istanbul. This is from Lisbon. Yes, you have to provide hydraulic grade line or energy grade line that that will allow water flow in the pipe. If you don't calculate these grade lines, you make the or construct the line, but water will not flow in it. So this is important. This is a technical part about it. So in all the calculations, what is related this with the basic science, all the calculations from the source to the distribution network, we use mainly two principles: conservation of mass and conservation of energy. This is main principles we usually use. A few other more, of course. These are pumping stations to give energy to water to flow. Yes, we are in Istanbul. Istanbul, this part European, this is Anatolian part. About 70% of population here, but 70% of the water sources are here. So it has to be a lot of transmission. Therefore, these are the pipes diameters that delivers water in Istanbul from different parts. Yes, there is, about water transmission line, there is an interesting project put in operation in 2015. We have supplied 75 million cubic meter water to Cyprus through Mediterranean Sea. Some pictures from there. This is Turkish side, Anamur, Akköprü Dam. This is Cyprus, Geçitköy Dam. And this line here, about 107 kilometers, but 80 kilometers of it is crossing the Mediterranean Sea. So, as I told you before, transmission line sometimes quite big part of the job. These are water treatment plants in Istanbul. We have treatment plant capacity of 4,400,000 cubic meters per day. And these are the big water treatment plants pictures from Istanbul. Yes, in conventional water treatment, we have coagulation, flocculation, sedimentation, filtration, and disinfection parts, but I will not talk about each of them because of the time limitation. But we can, if you like, during the break, we can talk. These are microsieves. Only it has micrometers level of openings to sieve out the small algae from water. That is very difficult to treat once it is in the system. So in the abstraction, if the water taken from lake or dams, there might be some algae grown, so microsieves is the good method to take them out from water. These are aeration constructions because waters are abstracted from either deep ground, which is anoxic, or sometimes if it is abstracted from lake or dams, it is abstracted from the deep sites. It has also limited oxygen dissolved in it. So there should be aeration process. And this is flocculation, coagulation, flocculation. Süremiz mi bitti? 2 dakikamız kaldı. Biraz daha hızlanalım. These are the coagulation, flocculation tanks, sedimentation tanks. Once the particles in the water coagulated, it is standing in the sedimentation tank or flowing very slowly. That particles density is bigger than water going down, so it can be taken out from the sediment. Precipitation is a bit different thing, but this is sedimentation. This is also, there are a lot of different types of sedimentation tanks. Some of them flowing horizontally, some flowing upwards. Usually upwards flowing tanks called clarifier. And then usually last process is the filters, sand filters, sometimes double layer sand and anthracite or activated granule activated carbon. And these filters could be gravity flow or pressure filters. And then, as I mentioned earlier, you have to have disinfection part. This is usually last process in treatment. And chlorine is the most widely used disinfection method. After chlorination, you need some contact time that the chlorine will kill the microorganisms. So you have contact time. Ozonization is very popular. You have to produce ozone in the site because you cannot store it. It has some advantages, but it lasts only at most half an hour. It kills the microorganisms and then gone. After any pollution happens, no protection. So even you have ozonization, you need some chlorination also. UV radiation is a similar process. Then we have water distribution. We should have a tank which will keep all the network under pressure. This is important because when you open the tap, water should flow. If there is no pressure, you cannot provide this. Another thing, if it is under pressure all the time, it is protected against the pollutions as well. Otherwise, some pollutants may enter the pipelines because pipelines network is thousands of pipes connected to each other, some holes, some. The best operated drinking water network has at least 10 or 15% loss. So this means it is leaking always. If it is not under pressure all the time, these leaking points can be pollution entering points. So it should be continuously under pressure. Yes, this is elements of the network. Some real pictures how network parts is seen on the ground. These are the examples of water storage tanks. Why some is like a tower, why some is buried under the ground? It depends the elevation. Because if the city or the streets are lower and you have some hills around, you can build a storage tank there and you can provide enough pressure for the whole system. But if there is no such place, you have to build a tower to keep the network under pressure. Therefore, some are built as a tower, some on the ground. And this is household connections. Every household has some connections like this. This is only the water supply part. There is another part which is wastewater disposal part that is not included here. So every household also have wastewater connection to the sewerage system. And thank you. I think